Okay, so let's recap the activity that we did today, talking about absolute value, and absolute value being the distance from 0, which means it is always positive. You cannot have a negative distance. So absolute value answers will always be positive. Okay, so we laid out numbered cards from -4 to 4 that showed the solutions for each value for x. Okay, so the first set of equations that we had, the first set were all equations. Absolute value of x equals some number. Okay, so what I asked you to do is write down the equations, and then you showed me your solutions with the numbered cards, and then after getting a thumbs up, you would write down your answer. Okay, so look at my picture that's upside down. We had for set 1, problem 1, the absolute value of x is equal to 2. So I asked you to show me on your cards what values could I plug in for x that would give me, after taking the absolute value, positive 2. So the answers were -2 and 2, because if I take the absolute value of positive 2, this right here, I get 2. And if I plug in -2 for x, and then take the absolute value of that, I also get 2. So there were 2 solutions there. All right, now, set 1, problem 2, we had the absolute value of x minus 2 is equal to 1. So we were trying to find values for x that would give us a positive 1. Most of us pretty quickly figured out that if I plug in 3 for x, 3 minus 2 is 1, so 3 is a solution. But another solution is where I get -1 inside the absolute value, because the absolute value of -1 gives me positive 1. So we had to figure out what value for x, when I take away 2, will give me a -1. So what most of us did in our heads mentally was we thought, okay, 1 minus 2 gives me a -1, and then when I take the absolute value of -1, I get a positive 1. So then my solutions were positive 1 and positive 3. Again, we write our answers this way, just showing this is a set of 2 x values. They're both x's. We put them together inside the brackets. Okay, so our problem 3. We have the absolute value of x minus 1 equals 3. So we're looking for values of x that when I take away 1 and then take the absolute value of that, I get 3 as an answer. Okay, so most of us pretty quickly thought, okay, if I get 4 and take away 1, that gives me 3. Absolute value of 3 is 3. But the other part of that is I need to find the number for x that when I take away 1, I'm going to write up here at the top so we can see, I get a -3. So if I think about it, what value of x that I haven't written down here yet, when I take away 1 will give me a -3, and that's got to be a -2. -2 minus 1 gives me a -3. And again, the reason why I'm looking for a -3 is because when I take the absolute value of -3, that's what gives me the positive 3 that's a part of my solution over here. Okay, so what we did, so our answers were -2 and 4. There's my solution, -2 and 4. So this is what we had you glue in your notebooks. We've got the absolute values, just basically a formula for you to remember. Absolute value of ax plus b equals c. The way to figure out the values for x is you set up 2 equations. You set up what's inside the absolute value, set it equal to c, c, which is the number out here on the right side of the equal sign, And then you also set it equal to the negative value of that, because once you take the absolute value of it, it gives you a positive. So let's work one of the examples that we did using that rule. So we had the absolute value of x minus 1 equals 3. I don't know why these pictures are upside down. They were not upside down whenever I did this. So anyway, so we got x minus 1. We take that, set it equal to 3. Solve for x, x equals 4. Then the way to find our second answer is to take x minus 1 and find where that is equal to negative 3. Because the absolute value of negative 3 will give me a positive 3. So when I solve for x, x equals negative 2. So if you're given a problem like this, where it's equal, this is how you solve it, by setting up two equations, and on the second equation you just make the answer on the right negative. Okay, so set 2, we talked about inequality absolute values that are less than and equal to. All three of these equations have the less than and equal to sign. So, first example was x is less than or equal to 2. So I need to find all the values of x that are smaller or equal to 2, including negative values, because when I take the absolute value of the negative values, that's going to give me a positive 2. So when we lined up our index cards, our solution became all of these values. So no longer are we having just two answers, but it's from negative 2 to positive 2. If I take the absolute value of negative 2, I get 2. That's less than or equal to 2. If I take the absolute value of negative 1, plug it in here for x, that's positive 1. 1 is less than or equal to 2. That's still a true statement. All 5 of these numbers, when I plug them in for x, are smaller or equal to 2. So the way I write my equation, my inequality, is this. X is a number in between positive 2 and negative 2. All right, example 2, or problem 2, was a little bit more difficult. We have x minus 2, some value of x minus 2. When I take the absolute value of that, it's got to be less than or equal to 1. So if I just plug in a number, say 0, I plug in 0 for x. 0 minus 2, that's negative 2, and the absolute value of negative 2 is 2, and that is not less than or equal to 1, so 2 cannot be a solution. Okay, so let's try a number that, or 0 cannot be a solution. Let's try 1. 1 for x minus 2 less than or equal to 1. 1 minus 2 is negative 1. Absolute value of negative 1 is positive 1, which is equal to 1, which I can have since I've got that little less than or equal to sign. So then negative 1 is part of my solution. Okay, and you just have to test out all those values. Just plug them in for x. Once you plug the values in for find that the values that make this inequality true are 1, 2, and 3. So x is a number in between 3 and 1. So 1 is less than or equal to x is less than or equal to 3. Set 3, or problem 3, x minus 1 is less than or equal to 3. So we're trying to find the values of x that after I take away 1 and then take the absolute value of that number, it's a number that is smaller or equal to 3. So again, I just have to plug in numbers. Let's start with, let's say 4. 4 minus 1 is 3. When I take the absolute value of 3, I get 3. And 3 is less than or equal to 3. So that is one of my solutions. Let's try 0. 0 minus 1 is negative 1. When I take the absolute value of that, I get positive 1, which is smaller or equal to 3. It's smaller than 3. So that is another solution. So plug in all the numbers to see what works and what doesn't. Come up with are all of these numbers. -2, -1, 0, 1, 2, 3, 4. Basically, the only numbers that don't work are -3 and -4. The only numbers that don't work for our particular solution set. So, the way we write that answer is -2 is less than or equal to x is less than or equal to 4. Okay, now, set 3 changes because every inequality we are looking at is now greater than or equal to. The last set was less than and equal to. This set is greater than and equal to. So, our first equation, we are looking for values of x that are greater than or equal to 2. So again, we just start plugging in numbers. For example, if I were to plug in -4 for x, -4, absolute value is +4, and that is a number that's greater than or equal to 2. If I plug in 0, absolute value of 0 is just 0. Oops, I didn't mean to write that. I meant to finish writing the inequality. Okay, so 0, that is not a number that's greater than or equal to 2, so that is not one of my solutions. So after I plug in all of those numbers, I figure out that the numbers that are a part of my solution is everything smaller or less than -2 and everything bigger or greater than +2. So my solution set looks like x is less than -2 or x is greater than +2. All right. Second problem, a little bit more difficult. We got to find values for x that when I take away 2 and then take the absolute value of that, I get numbers that are bigger or equal to 1. So let's plug in a value for x. Let's say 3. So absolute value 3 minus 2 greater than or equal to 1. 3 minus 2 is 1. And when I take the absolute value of that, I get 1. 1 is greater than, it's equal to 1. So that is part of my solution. Okay, let's try another number. Let's try a negative number. -2. Oops. I didn't take away 2 first. -2 for x minus 2, absolute value needs to be greater than or equal to 1. -2 minus 2 is -4. Absolute value of that is +4, which is greater than or equal to 1. So -2 is another one of my solutions. So after we plug in all of those numbers to figure out which ones work and which ones don't, what basically everything but +2 works. So x is less than or equal to 1 or x is greater than or equal to 3. All right, now let's look at the next slide. Okay, third problem. Absolute value of x minus 1 has to be greater than or equal to 3. So again, we're going to just plug in numbers. If I plug in, let's say, 3. So I'm testing whether or not 3 is a solution. 3 minus 1 is 2. Absolute value of 2 is just 2, which 2 is not bigger or equal to 3, so that can't be one of my solutions. All right, so let's try -3. 3 is not one of my solutions. -3 minus 1 is greater than or equal to 3. -3 minus 1 is -4. Absolute value of -4 is +4. And that is greater than or equal to 3. So then -3 is one of my solutions. All right, so after trying all of the different possibilities, my solution set is that x is less than -2 or x is greater than 4. Those are the numbers that will work to make this inequality true. Okay, now, I don't know about you, but I get tired of having to plug in number after number after number to see whether or not it works. There needs to be an easier way, right? Okay, well there is. There's a formula to use. And that's why I had you glue this thing into your notebook, because this is the formula that you are going to follow. Anytime there is a less than or equal to formula or absolute value, this is the formula that you're going to use. You take the negative of whatever this number is, put it here, put what's inside the absolute value in the middle, put this value here on the right, put the inequality signs in between, and then you solve it for x, and you're done. Now, that's when there's a less than, an equal to, or a less than, because it's going to make this kind of graph every time. Whenever you have a greater than or greater than and equal to, it's a little bit different. The pattern is this. You take what's inside here and your c, and for one equation, you keep them exactly the same. Ax plus b is greater than c. All we did was take off the absolute value sign. But then the other equation, to get your other values for x, you take what's inside the absolute value, flip this around. See here, it's greater than. Here it becomes less than. Take your c value and make it negative. And then you solve for x. And it works every time. So rather than having to flip over index cards and look at and test the numbers and plug numbers in for x, all we have to do is use these little formulas, and we'll get the answer right every time. Okay, let's do some practice. If we have the absolute value of x minus 1 is less than or equal to 3, the way we set it up is we take what's inside the absolute value, put it in the middle. Then I've got positive 3, put that on the right. Take the same value, make it negative, put it on the left. And then we just solve for x. So I add 1 to all three sides, and I get negative 2 is less than or equal to x is less than or equal to 4, which, if you will look, is the exact same answer we got with the index cards. Okay, let's try another one. X minus 2, this time it's greater than or equal to 1. So for the greater than or equal to, I use a different formula. I'll use this. First, we're going to take what's inside the absolute value and just leave it just like it is, greater than or equal to, and we're going to leave the value on the right the same. That's one equation. Now my other equation, I take what's inside the absolute value, x minus 2, I flip around the inequality, and then I make the c value, the number on the right, negative. That's how I set it up to get the answer right every time. So I'm going to add 2 to both sides on the right side, so x is greater than or equal to 3, or if I add 2 on the other side, x is less than or equal to positive 1. So usually this one comes first, the one that's pointing to the left. So x is less than or equal to 1, or x is greater than or equal to 3. And that is my solution set, which, if you'll go back and look at that example that we did from set 3, that's exactly what we got by turning over the index cards. The difference is, this time we used a formula to solve it, and the last time we just checked the numbers, plugging them in for x. When you get more complicated equations than what we have here, this makes it much, much nicer. All right, and the last thing I'm going to show is our little recap. This was the activity recap that I wanted you to do it for your journaling assignment in your journal. Okay, and hopefully this will help you understand the difference between when you have an equal sign. See, these are equations, so they had equal signs in them for step 1, and step 2 and 3. Step 2 all had less than or equal to, and step 3 all had greater than or equal to, and hopefully that's going to help you see the similarities and differences between those three groups. All right, and then just a reminder, our assignment for this page was, if I can find it, page 13 and 14 out of the workbook, numbers 2 through 28 even. And that's it.